Okay, we should be coming up on YouTube. Okay. All right, we are live on YouTube. And I'll pull us up on Zoom also so people can start coming in. All right, so people are starting to pour in. Shall we go over some of those spotted owl calls? Unless you changed your mind and you want to imitate some.
No, I would only embarrass myself before I have to talk about the owls. So
no, you'd be giving people courage to learn to imitate owl calls themselves.
Yeah.
All right. Let's go with this guy.
Yeah, so that's actually a pair of owls. And so the male is the one that is hooting with a typical 4-note hoot. And then the female can be heard in the background, the squeaky noise, which is their contact call that they do to the males. Oftentimes the males will bring in food when the pair is nesting, and he'll make that call when he arrives in the nest site, and then she'll make that contact call.
Okay, and then this should be female.
Yeah, you can tell it's a female because the pitch of the hoot is much higher than the one we heard earlier, which was the male.
So are all the females a lot higher than the males, or there's some that are difficult?
Generally, they're like with any birds, there's some variation. Each individuals have their own voice, so to speak, and so some of the females will sound lower pitched, and they'll be actually misidentified as males in the field until people find them with another male, and they'll be like, oh wait, it's actually a female with a very low sounding hoot. So
it's a good thing the owls know what's going on.
Oh yeah.
Let me find another one. Let's do not sure if that's going to go again. So is that just the female contact call?
Yeah, so contact call, pair contact call. And so that's a agitated female. And so they call that an agitated call because she'll often do that around the nest site if she has young or eggs, and she gets disturbed. Sometimes if, while people doing research, if they walk in near the nest site, she'll do that. Or in response to the Bart owls, if there's Bart owls around the nest, they'll start making an agitated call like that as well. So it's kind of, their disturbance, kind of an alarm call, but more just agitation.
Okay. This one is also listed as agitation. That sounds like really not a happy camper.
No, it doesn't. That you don't usually hear them going on that long.
Okay, and this is supposed to be a pair.
So yeah, so you can hear the male. He's a little bit more abrupt. The hoots are a little bit more abrupt and a lower tone.
And
so all kinds of stuff going on there.
video would sometimes help over just audio. And so for those who are listening, these are recordings from a CD set you can't get anymore, Voices of North American Owls by Cornell Lab of Ornithology. Maybe you can find a used set somewhere. But it was a magnificent CD set, 2 CDs, 99 tracks on one CD and like 96 on the other CD. The complete vocal repertoire of every owl species in North America, as well as was documented at that time, somewhere around 2005 when they came out. So you can probably find these recordings on All About Birds and in the Macaulay Sound Library from Cornell. But it was really handy when they were all condensed in one spot. Hopefully we've got everybody here, or as people come in, well, they can just join us. A little bit of background information first. If you haven't joined us before, I'm Carla Bloom from the International Owl Center. Not sure if you can see me or not. We're keeping the screen share up just to make sure nothing goes wonky here. And the International Owl Center is located in the Toe, in the southeast corner of Minnesota, in a little town, the little town of Houston. We're not in Houston, Texas. Houston, Minnesota is less than 1,000 people, but hey, we do owl stuff here. You will find that the chat is disabled in Zoom, but if you are joining us via YouTube, chat is live there. And if you're going to chat there, please do keep it on topic. We have some chat room moderators that may be able to answer some questions there and will help you keep things on topic. We will take questions at the end of the presentation. So if you're in Zoom, type those into the Q&A section. You can type those in whenever. We'll just address them at the end. If you're in YouTube, you can type them into chat and they will be forwarded to me to ask David at the end of the presentation. This presentation will be saved to YouTube so people can watch it later on. So if people are out enjoying wonderful weather today, like we're having awesome weather in the Midwest, it can be watched later. So thank you, David, for allowing us to save this. Also, thank you to everyone who's watching and everybody who made donations to help support this series. That's what allows us to keep this free for everybody so that everybody in the world who wants to learn can learn more about owls, because especially this one is really important topics. And today, I think we had people from at least 10 countries and 29 states sign up to watch this. So we do reach a really big audience. So no pressure, David, or anything. People are just watching all over the world. So yes, thank you, David Wiens, for doing this presentation for us. I asked a whole lot of people who should do a spotted owl presentation, and I kept getting pointed to David. So thank you for doing this on a Sunday afternoon or morning for you. It's almost, yeah, it's not noon yet. Morning for you. And a little bit of background about David. He's a raptor ecologist and research wildlife biologist with the U.S. Geological Survey in Corvallis, Oregon. He's done raptor research for over 30 years, which includes goshawks, golden eagles, spotted owls, and barred owls. And his most recent work focuses on the impacts of barred owls on spotted owls, which is a really huge, important thing. So David, thank you very much for sharing your knowledge with us. And with that, I will turn it over to you.
Well, thanks, Carla. I really appreciate the invitation to come talk about spotted owls today. And the very interesting story that surrounds this owl species in the Pacific Northwest of the United States. And so I'm going to go ahead and jump right in to the talk. And so here is the northern spotted owl, and northern spotted owls have a very long history in Western North America. It's a very important owl species. This owl species is actually single-handedly responsible for changing the entire management paradigm of forests in the Pacific Northwest, shifting the management paradigm from timber extraction focus to more of a focus on biodiversity conservation. And really the spotted owl is a key species that sparked that change in how federal forests are managed in this area of the world. Spotted owls have also become critically endangered, especially lately. Their populations have been declining rapidly. And so today I'd like to really go over some of the reasons why that may be happening, and including their history and you know, in terms of their conservation and management. I will also be talking a lot about this guy today. This is a Bart Owl that is invasive in Western North America now. It's closely related to the northern spotted owl. They're within the same genus. And the Bart Owl has become a major player in the spotted owl conservation story that I'm going to talk about today. So I did want to mention the Bart Owl. This guy will come in just a little bit later in today's story that I'm going to start. So just a little bit about what I'm going to talk about today and go over. I'll just begin with a little bit about the conservation history of northern spotted owls, because I think this is a really fascinating aspect of the story, how spotted owls got recognized as this very important species, an indicator of old growth forests in the Western United States. And then I'm going to go on to talk about the Bart Owl invasion of the northern spotted owl range and how that has impacted the northern spotted owl. And basically, the Bart Owl is responsible for throwing a monkey wrench into management plans that were built upon the northern spotted owl largely. I'll also talk a lot today about demographic research and field experiments that have been completed lately on both spotted owls and Bart owls. And then in today's talk with a little bit of a discussion about future directions and what's happening with spotted owls and management now as we begin to move forward in this new phase that I'll begin to talk about of management that we begin to embark upon. Just a little bit of background about this species. The northern spotted owl, as many of you probably know, is an old forest obligate. So it specializes in old forest conditions with tall, large, old trees. Within their range, these are generally forest types that are older than 150 years old, but can reach much greater ages as well. The species is long lived in the wild. They're recorded in the wild to live over 20 years. I think the longest record for an individual is about 22 or 23 years. And they have very strong site fidelity to their territory of mate. So in an ideal situation, once they settle on a territory, their breeding lifespan is spent on that territory with the same mate. The species also specializes on hunting flying squirrels, wood rats, and tree voles. In particular, these are three important species for this specialist owl species. Again, this owl species really specializes on old forest conditions. It also forages very much in the forest canopy of those older forests where these prey species can be found. So the northern spotted owls is one of the most intensively studied birds in the world, and probably the most intensively studied bird of prey in the world by far. It's an iconic species of old growth forests, and especially in the Pacific Northwest, where it's really seen as a representative of those type of conditions, and has been viewed as a type of umbrella species for older forest types. And as I mentioned at the beginning of the talk, this species is responsible for changing management practices on over 10 million hectares of federally forest lands. So no other species that's been federally protected under the Endangered Species Act has had a greater economical or political impact than the northern spotted owl has. And the northern spotted owl has been federally protected or received federal protection for over 30 years now. And so these are some of the conditions where you might find spotted owls in Western Oregon, the area near where I live. Large old trees and somewhat open understory canopies like you see here. Typical old growth conditions where you might find these owls. Here is just a view of the range of the northern spotted owl within the United States, spanning Washington, Oregon, and California, and over 23 million hectares of forested land. The real challenge with spotted owls has been historically the loss of habitat in those old forest conditions. And so here you can see the cover of older forest types that were estimated back in 1940 versus 50 years later in 1994, when the Northwest Forest Plan, which is a broad regional scale management plan that was based upon spotted owls, was first implemented. And you can see the massive change there in old growth cover that is largely a result of timber harvest during that period. And the timber harvest during that period was extensive. And so I mentioned the Northwest Forest Plan, and this is a very important plan management strategy for the Pacific Northwest, because once the debate over spotted owls had come to a head in the early 90s, this is the plan that was implemented that was across the federal agencies that were responsible for managing these lands. And so what happened with this plan is a network of late successional reserves and critical habitat designations that you can see here were established. These were established not only for northern spotted owls, but the entire old growth ecosystem and the thousands of other species that rely upon those specific systems. And so the spotted owl really was the instigator of this plan and formed the basis of it, but the plan was encompassing way beyond the spotted owl and across these entire systems. So it's an extensive plan. It changed forest management practices pretty abruptly in the early 90s. So during that time, this is what is sometimes has been referred to as the timber wars of the Pacific Northwest, when spotted owls were front and center of this controversy of logging old forests versus conserving these areas for the owl, which meant reductions in timber harvest and a lot of jobs lost. So you can imagine the controversy that was sparked historically by the northern spotted owl in the early 90s, when the bird was first placed on the Endangered Species Act and listed under that federal protection. So Rocky Gutierrez, who's another long-term spotted owl researcher, I really like the way that he's phrased this conservation issue as a wicked conservation problem. And he recently wrote an article about this issue in the Journal of Raptor Research. And I would recommend going and taking a look for those that are interested in reading about the history and kind of some of the political and social issues that surround the spotted owl problem. But it really boils down to a conflict between those who wish to conserve owls and old growth forests and those who wish to log those old growth trees as commodities. And so once the Northwest Forest Plan was established, and it's been in place now for about 30 years, a kind of balance has been reached that's somewhat tenuous at best. And so with this balance of this delicate management plan, the emergence of new threats can easily undermine those negotiated agreements. And new threats, such as the emergence of wildfire or Bart owls, that I'll talk about shortly. Essentially, these issues lead to intractable or wicked problems, as Rocky described these, that cannot be resolved to the satisfaction of most. And so this is really a situation with spotted owls where things have been balanced as best they can with management and logging old growth, but at the same time, not resolved to how everybody would like to see things. And so this continues to be a difficult problem. And of course, as I mentioned earlier, the spotted owl has become more and more endangered as time has gone on, despite these widespread protections of its habitat. And so around the time when the bird was first listed, they began these large-scale monitoring programs, demographic monitoring programs for northern spotted owls. And here I'm showing the distribution of 11 of these long-term demographic study areas for northern spotted owls that were established in the early 90s. And it went on for nearly 30 years. And each year they had armies of field crews going out and doing market capture studies of spotted owls, where they would go out, capture the birds, the adult birds on their territories, mark them with leg bands individually so they can be identified and their survival and reproduction can be tracked over time. And so this was a massive effort to understand the ecology and demography of northern spotted owls across their geographic range. 30 years later, based on these studies, we find that their populations have continued to decline rapidly, despite the widespread habitat protections that were put in place that I went over with you earlier. And so you can see in the graphs here from one of our recent publications that we put out just last year, where we took all the demographic marker capture information from all of these 11 study areas and analyzed the data jointly to determine population trends of the species across the range. And you can see the population trajectories for each of those 11 study areas there, and all are negative and declining rapidly, particularly in the northern portion of the Owl's range. Up in the Washington area, where less than 35% of the population that was there in the early 90s actually remains now. And even less than that 35% exists in those areas today. So very rapid declines that continued despite the widespread habitat protections that were associated with historic population declines in northern spotted owl. So really the question is, well, why have these spotted owl populations continued to decline despite this massive amount of effort and funding commitment that has been put in by not only federal agencies, but state, private agencies, a huge amount of effort, yet their populations continue to decline. And not only are those populations continuing to decline, but those declines in some cases are even accelerating in some cases. And so there's a lot of different things, a lot of different stressors on spotted owls out there, including increases in wildfire that we're seeing with changing and warming climates. Also, we're seeing continued timber harvest on private lands and within the range of the northern spotted owl, even though that has been substantially reduced on federally managed lands. Also, the changes associated with a warming climate in the Pacific Northwest and changing temperatures could be creating that. But really what I'm going to start pointing to and start talking about is the Bart Owl on the lower right hand of the screen there. This is a very important other owl species we'll soon learn about here. So before I get to the Bart Owl, I wanted to talk a little bit about the effect of historical and continued habitat loss. So this is an area just showing a portion of Western Oregon and the distribution of forest cover in 1987. And the red dots there are forest disturbance, timber harvests. They can also be small wildfires or insect outbreaks that disturb the forest. And as we go through time, here's what that landscape looked in 1990 when the northern spotted owl was listed under the Endangered Species Act. And you can see over time that even though the forest plan was implemented and much of the timber harvest was halted on federal lands, it continued on much of the interspersed private lands in these areas, even after the plan was implemented, as shown here. And so that trend continues. And so there's still this issue of habitat loss. But overall, that has not become such a major issue for northern spotted owls, particularly on federal lands. And in fact, they've even begun to measure some increases in habitats used by northern spotted owls within the last several years. That's before these large mega fires began occurring in 2020 in Western Oregon and in Washington and in California. And we've seen massive wildfires go through some of these old growth stands and destroy much of the old growth spotted owl habitat that's been protected all these years. And so this is another emergent threat to spotted owls. But really the biggest, most immediate threat by far that we've discovered is this guy, the Bart Owl. So the Bart Owl is a native species to Eastern North America. And so here I'm showing the species historical range. This is the range of both these species around 1900 or so, around the turn of the century. And so you can see that these two species were geographically isolated, and Bart Owls were restricted to Eastern North America. Well, around that time, they began to expand their range westward. And this is what we believe the range of Bart Owls looks like today. A massive range expansion by Bart Owls. This is a huge continental scale event that is quite incredible, actually, if you think about it. Particularly from my point of view as a raptor ecologist, a lot of the work I do focuses on birds of prey that are declining and facing substantial stressors to their population. Whereas here we have the Bart Owl, where it's just the opposite situation. The bird is thriving and expanding and has expanded its range across the continent rather quickly. But as you can see now, this range completely overlaps that of the northern spotted owl. And Bart Owls have now begun to move southward into the range of the California spotted owl subspecies, began to interact with the California spotted owl, which is another subspecies, which is not yet reached as critical a threatened stage as the northern spotted owl. But they're looking at these Bart Owls moving into that range, and there's increasing concern about their impacts on that species as well. So why did Bart Owls move west? What instigated this large continental scale range expansion? Well, there's several hypotheses, but really there's the main one that has been put forth that has the most credibility is that the range expansion was coincided with European settlement of the Great Plains region of Western North America and Central North America. I think one of the main questions about Bart Owl range expansion is how they crossed the Great Plains region, which was largely treeless region at that time. So a forest owl species, how did they cross that massive expanse of grasslands? And during the time of European settlement, as they moved across those grasslands and began to settle those areas, they began planting shelter beds of trees. And there were several other ecological changes that began occurring that coincided with European settlement that likely facilitated that expansion by Bart Owls. This is not definitive evidence. There's also some evidence that there were some warming climate trends in the boreal forests of Canada during the 1900s that could have facilitated the range expansion as well. It may have been a combination of these things, you know, a warming climate around that time and as well as European settlement. nonetheless, these are just hypotheses associated with the range expansion of barred owls. But regardless, they're now in Western North America and interacting with spotted owls. And so here, just showing how closely related these two birds are. Barred owls are slightly larger. They're about 5 to 10% larger in body size than spotted owls. And they're also a generalist species. So as opposed to spotted owls, which are specialists on old forest systems, barred owls are more generalists. So they also specialize on old forest systems, but they're more generalist in their preferences in that they can do pretty well in younger forests. And they also eat a much broader array of prey species than spotted owls too, which I'll talk about in a minute. And now I'm going to show you a little bit about what the issue with barred owls is. And so here I'm showing the 3 study areas of these long-term demographic study areas for spotted owls that I told you about. These are 3 study areas that were established in Western Oregon along the coast. And each of those red dots is a detection of a spotted owl in the landscape. And each blue dot is a detection of a barred owl in the landscape. And these birds are detected as these crews go out and are surveying these areas intensively during the breeding season of each year. And so in 1990, around the time when spotted owls were first listed, you'll see that there are very few barred owls in these landscapes. They had begun appearing in these forests, but they were very sparse, very few of them, and they were basically an anomaly in these landscapes that were largely dominated mostly by spotted owls at that time. As these studies began progressing and monitoring spotted owls, they began also noticing increases in the number of barred owls in these areas. And so by 2002, in the early 2000s, they started noticing very rapid increases in barred owls in these areas. They started detecting lots of barred owls. And so this is just a picture of what things looked like in 2012 before we started some serious research on barred owls in these areas. But you can see the situation here of what's happening is as barred owls begin to inundate the landscape, spotted owls are beginning to disappear. And we're finding fewer and fewer spotted owls and more barred owls in the landscape. Not only that, the barred owls that were being detected at the nest sites of spotted owls. So barred owls were coming into these areas, displacing spotted owls from their old growth, often protected nesting territories. And it was completely unknown what was happening to the spotted owls. They just weren't being detected anymore once barred owls showed up. And so these long-term demographic studies started monitoring these trends of the 2 species. And here you can see in each of the 11 long-term demographic study areas I mentioned, the trends in spotted owls and barred owls that they monitored since 1993. So this data I'm showing you here is territory occupancy data from 1993 through 2018. So 26 years of data looking at changes in northern spotted owls, the purple lines, and changes in 1 or more barred owls being detected within those breeding territories. And you can see the pattern is the same on every one of those 11 study areas. As barred owls are increasing, spotted owls are decreasing rapidly. And so at the time, this was a real dilemma because, and it continues to be today, because as I mentioned before, barred owls are a native species of North America. Now you have a native species that's become invasive within the range of a critically threatened owl species and having a very negative effect and impact on that owl species. And so one of the first things that really began to enlighten what was happening in this situation is some of the research on competitive interactions and resource partitioning between these 2 owl species. And I'd like to just go over with you quickly a few of the key findings from that research that helped move things forward to where we are today. So I was able to complete some of this research, and I completed it with Eric Forsman and Bob Anthony, who served as my advisors on this research. It's a great opportunity to be able to work on this issue, and really the first time that I came in to be able to work on spotted owls and barred owls in this area. We did a large radio telemetry study on the two birds, where we went into this landscape of Western Oregon, and we captured and radio tagged about 60 individual owls, 30 owls of each species. So we had about 30 barred owls and 30 spotted owls radio tagged, all in adjacent territories. And you can see all the locations that we got for each of the birds there. The spotted owl locations, individuals in red there, and the barred owls in blue. And then within those areas, we could do this intensive research to look at how the birds were sharing habitat, sharing space, and sharing prey within these areas where their home ranges were overlapping with each other. And it gave us a very detailed, close look at how the two species were partitioning resources and how spotted owls were dealing with this new intrusive barred owl in their forested landscapes. So this study really taught us a lot about habitat use and diets of barred owls. In the bottom right there, that's a photo of a barred owl picking an earthworm out of somebody's lawn. I stuck that in there just as an example of how flexible and adaptable barred owls are, and what a generalist prey predator they are. It's amazing to me to look at that photo, because the owl is picking a worm out of the lawn just like you would see a robin doing. And so it's quite amazing. Also, barred owls are quite amazing in the sense that they can be quite focused on the aquatic environment we discovered in this study. They eat a lot of aquatic prey species, including a lot of snails and fish and crayfish and things like that. Things that you don't see spotted owls eating. And so this study, as I mentioned, it gave us a lot of information about how the two species were interacting as well, spatially. One of the things that we discovered from the radio marking these two species in adjacent territories with each other is that barred owls were essentially excluding spotted owls from their core use areas where their nesting areas were. And so even though we found a lot of overlap in their broader foraging areas, around their nesting areas, barred owls were essentially excluding spotted owls from those areas. Yet spotted owls were unable to successfully exclude barred owls from their nesting areas as effectively. So a big difference in how the two species were interacting. It's clear that the barred owl was dominant in this type of competitive interaction situation. We also looked at overlap in diets. So in this telemetry study, we could go out and collect the pellets that the owls regurgitate. And we spent thousands of hours in the lab dissecting thousands of pellets, tiny, tiny little bones, and identifying each little bone to determine what their diets are. And it all boils down essentially to this graph I'm showing you here, with the spotted owl on the left and the barred owl on the right. And you can see that the barred owl's diet is much broader, much more generalist, as I mentioned before. So whereas the spotted owl's diet is really dominated by mammal species, and not only that, by just a few in particular species that I mentioned earlier, like the wood rat, the flying squirrel, or the tree vole. Whereas the barred owl is eating a lot of other stuff, particularly a lot of amphibians that we found that they're preying upon in these landscapes. A lot of frogs and salamanders, which is very different than spotted owls and very different from other owl species in the Pacific Northwest. So this is something that barred owls as an invasive species are doing that's very different from the other owl species that are native to these forests. So barred owls are likely having a much broader impact on these systems based upon their generalist diet and their numbers and densities of their individuals that we're seeing in these landscapes. And there are many, many species that they could be impacting in these forests. And these are just some of the few that I'm showing here that we identified in their diets. And yeah, they do eat a lot of insects and beetles too. So that was another really interesting thing about barred owls, to me particularly, is that they can eat pretty large prey, snowshoe hares, things like that, that they're able to take. But they can also do well just eating a lot of really small things. So sometimes we would find one pellet that was consisting nothing but of beetle remains. And so the bird is going around just eating hundreds of beetles or millipedes or snails, things like that. On the other hand, they're also eating many, many small mammal species like red tree voles, which is a sensitive tree vole species that inhabits canopies of older growth forests. And so barred owls are likely impacting many other species and having larger ecological effects in these systems where they're newcomers. And of course, this has not boded well for the spotted owl, as I've alluded to. The spotted owl has been outcompeted by the barred owl and essentially driven out of these older forest types by the bird. And then we're seeing very sharp population declines that are directly attributable to barred owls. And so this really instigated the need and the management question of barred owl removal, and really address these two major questions that emerged over barred owls. The first one was, can barred owl removal improve declining population trends of spotted owls? So if barred owls are removed from these older forests where they've become invasive and they've impacted spotted owls, can we reverse these declining population trends of spotted owls that we're measuring? The other question is, what is the effectiveness of barred owl as a removal as a possible management tool? So by conducting a field experiment, a removal field experiment to learn more about this, we can learn not only about the barred owl's role in the population declines of northern spotted owls, but also about the viability of barred owl removal as a tool to recover spotted owl populations and likely many other wildlife populations that have been impacted by barred owls over the past couple decades now. To do a large-scale field experiment where you're doing lethal removal of a big, beautiful owl species like barred owl is not something that anyone takes lightly. And there's a lot of thought and effort put into whether or not this experiment should even be completed. So there's a lot of discussion about ethics and science and barred owls. And what the management agencies did is they convened a barred owl stakeholder group, which consisted of all these different stakeholders that I'm showing you here, to talk about this decision of, should we conduct an experiment to learn more about if removal of barred owls can benefit northern spotted owl populations. So once this group of stakeholders got together and had meetings, they went out to the field in a couple of cases to see barred owls and spotted owls. And once they became informed and educated about the ecological dilemma that was occurring, it was a unanimous decision among these stakeholders to conduct an experiment, to move forward with at least conducting an experiment. The alternative was to not conduct an experiment and just let the chips fall where they may, not learn from the situation, and most likely be making that decision that spotted owls would just go extinct. And so this very hard decision, even to conduct this removal experiment that I'm about to talk about. But the decision was unanimously to go forward, to not let the northern spotted owl go extinct, and to attempt to learn as much as we can from this experiment. So a little bit of background about this large-scale barred owl removal experiment that occurred between 2009 and 2020. So we replicated the experiment on these 5 different study areas within the range of the northern spotted owl that I'm showing here. And so each of these areas was a spatial replicate within a larger experimental framework. Each of these areas was then split into 2 or more control and treatment areas. And when I talk about the treatment areas, those are the areas where we're removing barred owls. The control areas are areas where we're leaving barred owls alone and continuing to monitor what happens to barred owls and spotted owls when you're not doing removals. And so then we go in and we survey all those areas, the control and treatment areas for each owl species, and we do that annually between March and September of each year. And then all the barred owls that are identified during the surveys are then removed from those treatment areas. And that occurred over a 4 to 6 year period during this study. And I'll talk a little bit about how the barred owls were removed in a minute. But what I really want to drive home is that this was a very unique and powerful study, because it was based on these long-term demographic studies of northern spotted owls, and it occurred in those study areas. So this gave a very precise estimate of exactly what was happening with spotted owl survival, recruitment, and rate of population change before removals, and then what happens to those rates, vital rates of spotted owls once you start doing removals. So a very powerful experimental design that you rarely see in field studies, particularly with raptor species. And so this is really one of the largest field experiments that's ever been conducted on birds of prey, and likely birds in general. And so I'll just go over quickly, show you a little bit about what this experiment was about. This is our study area in Western Oregon. And what I'm showing here are the individual historical territories of northern spotted owls. So each one of those polygons was an area where we monitored a pair of spotted owls since 1993. So each of those areas in 1993, over that period of time, had been occupied by at least a pair of spotted owls. And so here you can see in 2015, this is the year before we began removals in this area. You can see the distribution of red dots there representing where we have spotted owls in this landscape when we began the study. And so the blue polygons are the control polygons where we did not remove barred owls, whereas the red areas are areas where we did remove barred owls. And so we also then in 2015, before we did any removals, we went in and we surveyed the barred owl population in this area, and basically did an intensive survey to determine what we're working with. And this was very interesting aspect of the project, because this was really our first intensive survey for barred owls in the landscape. So it was our really first impression of what we were dealing with in this landscape, because a lot of the measures of barred owl occurrence prior to the study were just based on northern spotted owl studies and these ancillary detections during those studies. No studies had been done specifically on barred owls or surveys. And so we went into this landscape and surveyed it intensively for barred owls. And this is what we found, very different than what was happening with spotted owls. So each of those blue dots on that map is a pair of barred owls that we identified in this landscape. And so that is a lot of barred owls. They were absolutely inundating this landscape. Some of these territories, individual territories of spotted owls that historically supported one pair of spotted owls, we detected as many as 5 or 6 pairs of barred owls within a single spotted owl territory. So this really illustrates how barred owls can reach much higher densities than spotted owls. and really have major impacts, not only on spotted owls, but a lot of other species that are in these forests, as you can imagine. So as we progress with the study, then we go into those removal areas, the red polygon areas, and we remove all the barred owls that we can. And so those barred owls are lethally removed using shotguns. And so this is a look at what the picture looks like with 5 years of removal efforts. So in 2020, this is the end of the experiment. And so I'll kind of flip back and forth there. And we've really, first, you'll see that we've really thinned out the barred owl population within that treatment area. The other thing you'll notice is that the treatment area by the end of the study was really the only place where we had spotted owls remaining in the landscape. So going back 5 years earlier again, you can see in those blue polygons, there are quite a few spotted owls left still. 5 years later, they were gone, impacted by the barred owls where we hadn't been doing removals. Whereas that area where we have been doing removals, not only had the spotted owls began to hang on to their territories in there, but we had began to see some recruitment of new birds moving into that area. We also see barred owls moving back into those treatment areas very quickly after the territorial residents are removed. We see them recolonized by barred owls from the surrounding landscape very quickly. And so this is a graph just showing the picture of the barred owl population on control versus treatment areas during our study period. And you can see that the treatment area there in red, we did see a decline in the population, whereas it's increasing or remaining constant in the control. So strong evidence that the removals were successfully reducing numbers of barred owls and also benefiting spot owls. A little bit about the removal methods that we were using. We as I mentioned, there's a lot of discussion about how to remove barred owls. One, and it basically came down to two choices: doing lethal removal with shotguns, which was quick, cost-effective, and frankly, probably more ethically justifiable. Then the alternative was to do relocations, to trap barred owls, capture them, and relocate them somewhere else, or hold them in captivity for the duration of the experiment. That not only was not cost effective, but some of the initial research they did with telemetry and relocation up in Canada showed that some of those birds actually find their way back to their original capture location. And also the issue was, well, where are you going to put the birds once you catch them? There's really nobody that wanted barred owls. And also there's issues about mixing genetics of West Coast barred owls that may have changed with East Coast barred owls. Regardless, the study was done very carefully, and we used highly trained folks to do the removals in these areas. We also were careful not to do any removal of nesting barred owls, because the last thing we wanted to do was to remove a pair of barred owls that had young somewhere, and then those young would end up starving to death because they weren't being fed. And so we basically didn't do removals during the breeding season in a lot of these areas. And if we did, we made sure that the birds were not nesting before they were removed. And so something I want to emphasize is that all the barred owls removed in this experiment were collected, prepared as scientific specimens, and have been used for many other studies now in research projects. For example, one of the things that we've done with these specimens is doing large-scale testing for anticoagulant rodenticides in the environment. Barred owls can serve as a sentinel for contaminants in older forest systems. And so we've been able to use these specimens to begin to test for contaminants in the system, and have done some work on that with these specimens as well. So my point is that it was really our goal to use these birds to learn as much as possible if we're going to be doing this activity of lethal removal. This is just to give you an idea of the number of birds that removed total during the study in the landscape. You see the number of birds removed in each of those 5 different study areas. The areas where we removed more barred owls were areas that had higher densities of barred owls. So the Oregon Coast Range, for example, had very, very high densities of barred owls. That's a study area that I showed you the figure from just a minute ago. And that's where we removed the most barred owls from. But all in all, over 3,000 barred owls were removed during this experiment. And so the experiment was very successful. As you can see here, we did a large analysis of all these study areas, and we just released these results last year in the proceedings in the National Academy of Science in the publication that you see there. And we looked very closely at apparent survival of spotted owls, recruitment, and their rate of population change. And in each of those vital metrics for spotted owls, their population metrics, we saw a pretty substantial effect of barred owl removal. So in these graphs, the treatment or removal area is a survival or recruitment or the rate of population change with spotted owls without barred owl removal versus with barred owl removal. And that black vertical line represents the date that barred owl removal was initiated in each area. So you can clearly see that once barred owl removal is initiated, we start to see a change in the treatment area, whereas we're seeing continued reductions in those vital rates on the control areas without removals. So we conclude from this study that spotted owl population trends stabilized in areas with barred owl removal, whereas they continued to drop sharply in areas without barred owl removal. Another key finding from this study, that recruitment of new spotted owls. And so when I talk about recruitment, I'm talking about new individuals that have not been in the breeding population previously being recruited to the breeding segment of the population. And so these are new birds that weren't previously there when we started, new spotted owls moving in. We didn't see a lot of that. We didn't see a lot of recruitment, and the level of recruitment that would have been necessary to reverse the population decline rather than stabilize it was not there. So in other words, there was insufficient recruitment of new spotted owls into the population to cause population growth, but we did see a stabilization in the population decline. So there I'm just showing the mean effect size. This is the exact measure of the change in survival or recruitment or the population rate of change that was directly attributable to barred owl removal. And you can see very strong and positive effect on survival. It was a positive effect across all study areas, but not as strong for recruitment, as I mentioned. But then the annual rate of population change, we see that for all 5 study areas, we have a consistent positive effect of a positive increase relative to control areas without removal. So very, very strong evidence, not only that barred owls were causing population declines of spotted owls, but also that barred owl removal can successfully halt the long-term population declines of spotted owls that we've been monitoring over the past 30 years now. So a very powerful and meaningful result from this study. And also a very clear one was obtained as well. So the key takeaway here is that barred owl removal, as I mentioned, had a very strong positive effect on survival of spotted owls, and that effect was consistent across all 5 replicated study areas. And we saw that barred owl removal arrested population declines of spotted owls, but it did not reverse the population. So maintaining spotted owls in these landscapes will depend heavily on reducing the impact of barred owls. while addressing other threats to spotted owls I mentioned before, like habitat loss, disturbance, and changes in the fire regime that we're seeing. Another thing that's a main conclusion from this study is that there are very, very few spotted owls remaining in the northern portion of the bird's range, especially up in Canada and northern Washington. Very small percentage of those populations remain. It's a very dire situation up there. Very few spotted owls left. Another main conclusion we have is that barred owls are very high densities now. This is a new apex predator in these systems, and so they're likely having a lot of impacts on other native wildlife as well. This is one of the species that I think a lot about, and I think barred owls may also be impacting heavily, is the Western Screech Owl. Western Screech Owls not only use and may compete with barred owls for some of the same resources, but we've also recorded barred owls preying upon screech owls as well. And so screech owls could be heavily impacted, and we're starting to see some evidence that their populations are also starting to dwindle to very low levels in some of these areas where historically we were detecting a lot of screech owls. And we believe that this is largely because of barred owls. So moving forward, just briefly, I'm about to end here. Right now, the Fish and Wildlife Service and several other federal management agencies have the results of this large-scale removal experiment in hand, and they're using those results to now develop a large-scale barred owl management strategy that would be implemented across Oregon, Washington, and California if it's decided to implement the plan. So the goal of this large-scale management plan for barred owl would be to not only provide suitable habitat for spotted owls, but with reduced competition from barred owls. So that management plan, should it be decided to move forward, it'd be an adaptive reserve design type of framework across the range of the northern spotted owl that would build upon the results not only of the experiment that I went over with you, but it also build upon the results of the management actions as they were implemented. So it'd be an iterative, adaptive framework that would build as it progressed. It is unknown if lethal removal of barred owls would be the main strategy used in this management plan. But right now we do know that it is the only cost-effective and viable strategy that is available. It does not mean that others cannot emerge in the future and that we will not continue to look for those other methods. But I also want to emphasize the broader ecological impacts that barred owls are likely having on many other species. Particularly not only worried about some of the smaller native owl species, but amphibians are another group that barred owls are really feeding upon heavily in the Pacific Northwest. And this is a group that's already facing its own problems. So and clearly another stressor as well. And with that, I think I'm going to wrap things up today. I really appreciate your time and everybody's time. It's been a real honor to be able to go over this very interesting story and some of my research with you all today. And so I really appreciate that opportunity. Thanks, everybody. And I guess we'll dive into some questions, maybe.
Yes, thank you very much, David. If you want to stop screen sharing, then we can, that's a beautiful ending slide though. If you want to stop the screen sharing, then everybody can see you bigger.
There we go.
There we go. Okay. I was taking notes furiously because this is something we talk about at the Owl Center every day in our programming. And it's just this ethical, like, what do we do about this kind of thing? It's not straightforward like most things.
No, whatever you do is distasteful for what it comes down to, and there's no easy decision. There's very difficult decisions moving forward on whether or not to manage barred owls.
Yeah, and we of course are in part of their native range. So, yay, we like barred owls over here.
Yeah, and that's how, I think everybody feels about, nobody wants to get rid of barred owls completely out here. The goal is to have, 2 Strix owl species, not just one, right? And so we really like barred owls. The goal of these plans is not to eradicate barred owls. That would be impossible, clearly. So the goal is to reach some sort of coexistence with these 2 species.
Okay. Joe, do you want to lead off with a question?
Yeah, did you have any mortalities related to the radio tagging you did?
Yes, we did. Well, that was very interesting. Thanks for bringing that up. With the barred owls, we had very few mortalities. They have very, very high survival rates. We only had a couple barred owls that we found that were mortalities. And interestingly, I think one of them was probably because of contamination of some rodenticides that it had gotten into. And then the other one was the cause of death was some parasites in its stomach had killed the bird. But it was interesting because we also were monitoring mortality in spotted owls in that study, and we found a much higher mortality rate. And a lot of the spotted owls in that landscape were basically feeling the effects of competition with barred owls. So we were finding starvation was occurring, and which may be competition with barred owls for prey. And we also found that some of the spotted owls were diseased with different types of disease. So, disease, starvation, and also predation was a big one. Great horned owls are known pretty well to predate on spotted owls occasionally, and we did record that in that study as well. We had one case where we thought we might have had a barred owl that predated a spotted owl, and that's not been recorded directly. There is some evidence that barred owls may actually kill spotted owls directly, but not much. But we were really able to confirm that in that study, that there was any kind of direct killing going on. Most of the predation events on spotted owls we were able to attribute to great horned owls, actually.
Here's a question that's popping over from YouTube. At which point can we say that the western expansion of the barred owl population, even at the expense of the spotted owls, is a normal evolutionary displacement by a better adapted species?
Yeah, that's a tough one because, I think a lot of the questions that I've heard people asking is, well, why do barred owls have such an advantage over spotted owls in the Pacific Northwest? And one of those reasons can be is, well, spotted owls now have less than 30% of their habitat that they once occupied remaining. And that is a human caused event, largely responsible for that. And so, I think to some, there's the question of, well, if is this trajectory that both of these species are on now actually human caused because of what's happened to the old growth forests in the Pacific Northwest. And so if you look at things that way, I don't know if you can say that, hey, if all these forests were still intact, would barred owls have still been able to come into the spotted owl range and outcompete spotted owls? I don't know if we can answer that, but I think it's something worth thinking about in terms of that question. And then moving forward, I think it's just the real ethical question to me is whether or not we move forward with some management of barred owls, which would likely take the form of lethal removal, or we decide not to do that and we let the spotted owl go extinct by making that decision, because that's likely what will happen without barred owl removal. And so by not doing barred owl removal, you're making the decision to let spotted owls go extinct. and perhaps many other impacted species like some of the amphibians or small mammal species that are already threatened that are now we know are being predated on very heavily by barred owls. And so even though barred owl removal and lethal removal is not something that anybody likes or wants to do, it's also a very effective management tool to protect biodiversity in these unique systems, I think, at this point. So it's a really tough one that I constantly struggle with. And I think we're doing the best we can with it.
A couple people have asked about interbreeding between spotted and barred owls. Can you talk a little bit about that?
Yeah, that's another really interesting aspect of the situation. And so as barred owls first moved into the northern spotted owl range, there was a lot of interbreeding going on, and they were producing what people would call sparred owls, which is a spotted owl, barred owl hybrid. And so this is really something that was occurring quite a bit as barred owls were first moving into the northern spotted owls range. Where we're at now, though, is some of those photos I showed you, those figures, there's so many barred owls that we really aren't seeing that hybridization rate like it once was. And so there are really very few hybrid owls left in the landscape that we find in Oregon and Washington anyway. What's very interesting to me about the situation, I mentioned a little bit about how barred owls are now moving into California, particularly the Sierra Nevada, into the range of the California spotted owl. And so as that has been happening, there's been a lot of hybridization happening between barred owls and California spotted owls. And they're finding a lot of hybrid owls down there in the last several years. It's a very interesting situation because the hybrid owls, the sparred owls, are in and of themselves, they're this completely different owl, very interesting characters. Their calls are completely bizarre. They are truly a mix of spotted owls and barred owls, like the bird's confused and figuring out which call it wants to do. And some of the birds that they've captured down the Sierras are fascinating because they sent me a picture of one bird that basically had the plumage of a spotted owl, but then its tail was that of a barred owl. And so these really interesting genetic mixtures happening between the two species. I think it's a really interesting question.
So I think we had talked the other day when we were doing a test a little bit about when they are hybridizing, so that's like the leading edge of the barred owls moving in, but then it's typically a female barred and a male spotted because the female is larger.
Right, because there's the sex difference or dimorphism between the owl species, and the females are a little bit larger in both. They tend to retain that when they pair. So the male, we tend to find male spotted owls paired with female barred owls pretty regularly. And so, I can't tell you in our removal experiment, we had a couple situations where we had a male spotted owl paired with a female barred owl at a territory, and they would be producing young. And then there's a lot of discussion about, well, should that barred owl be removed as part of this project, even though it's mated with the spotted owl? And essentially the decisions by the agencies and us was, well, basically that barred owl is taking a territorial spot that a spotted owl could have, that it's not able to attain because that barred owl is there. And so in those situations, we did go in and we would remove the female barred owl of the pair. And interestingly, in those situations, a couple years later, a female spotted owl showed up. And so the male then paired with the female spotted owl, and in one case, then they successfully fledged young. And so that's just one kind of example of kind of difficult decisions that we had to make in this project, but some of the outcomes of those decisions as well.
And just to clarify also, those spart owls, the hybrids, they can't interbreed with each other, correct?
Yes, I don't believe so. Yeah, I don't, I think that the hybrid owls can then back cross with the parent species, but not with each other. Oh, I can't hear you anymore.
That's why Joe was doing this.
Oh.
No. Why would any reasonable person not expect the barred owls to simply return to the removal areas over a fairly short period of years? So do you want to address how that gets addressed?
Oh, yes. So, yeah, we knew just based on the population ecology of these birds and raptors in general that, you know, once you go into a territory and you remove that territorial pair, that pair is going to be replaced by colonists from the surrounding area. So we knew that there would be that issue. We didn't know how extensive it would be, but sure, that's part of the population framework that these species have. That's part of their buffer mechanism to buffer against increase of mortality at those territories of the adults. What we found is that barred owls are very, very aggressive. And so when we go in there with territorial calls, they're very responsive. It's fairly quick and efficient to remove barred owls actually from these areas because they're so aggressive and responsive. And so what we found is that in these landscapes, most of the areas were just completely inundated with territorial pairs, and we're able to successfully remove all those pairs that were originally there. And then once we remove them, they start being replaced by the younger birds that are floating around, maybe not have territories in the surrounding landscapes. But as soon as they settle on a territory, they're going to have to be responsive and start defending that territory. And by doing that, they become susceptible to become removed by us. And so by our crews keeping a constant effort in those areas and going out there week after week, year round, we're able to quickly remove the birds as they recolonize. And so by doing that, we think that they really didn't have a chance to fully establish their territories. And thus they didn't have a chance to fully impact the spot owls that were in that landscape. So even though we're seeing a high rate of recolonization by barred owls after we remove them, the birds coming in to these landscapes are not there very long before they're removed. And another thing is that they're just beginning to settle on territories. So they're not as quite established and not quite as competitively dominant to spot owls that are well established in those areas. So there's a big change in the dynamic of the barred owl population once you start doing removals in terms of the new birds. Their experience and their abilities are different. And so that could really translate to differences in how they're competing with spotted owls. But it's a great question because it's a really important aspect of this whole dynamic that goes on. And it also means that, you know, once you stop doing barred owl removals, that those areas quickly fill up again with barred owls. And so this brings the inevitable question for a management strategy. If you start implementing barred owl management, can you ever end? Or is it an indefinite type of thing that would be required? I don't think we would really know the answer to that yet.
One person says, I take it that putting a bounty on barred owls is not an option, as most people would have trouble identifying the barred owl versus the spotted owl.
Yeah, this question has come up before, and there's actually an initiative to get a bounty for barred owls in Oregon. That didn't go through, but there was an initiative. But it would be problematic just for the reason you mentioned, is that it takes some training to be able to distinguish barred owls and spotted owls. And once you know what to look for, it's pretty easy and straightforward. But if you had a bounty in the general public going out there, there could be easily mistakes made and spotted owls being removed instead of barred owls, and completely working against what we're trying to achieve. However, it doesn't mean that I don't think something like that can't be ever achieved. And it may be one route that could be taken in a long-term type of management plan. It just would require some pretty intensive training before people would go out there to collect any bounty, to make sure they know what they're doing. Frankly, I don't see it happening, but it would be a way to get the work done in a more cost-effective way. And so it has been mentioned and brought to the table, but I just don't see it happening.
What about having a special breeding program for the northern spotted owls with the goal of returning the forest to expand the northern spotted owl population?
Yeah, that's a really great question. I'll mention a couple things in response to that. First, that there is a captive breeding program taking place in British Columbia in Canada, where they've successfully captive bred northern spotted owls. Their population in British Columbia is in very dire shape. There's basically just a few birds left that they collected out of the wild to do captive breeding with. The program has been successful in breeding spotted owls. And my understanding is later this year, next year, they're going to start to reintroduce those captive bred owls back into the wild, which I think is pretty exciting. There's also, so that's one thing. The other thing is, I mentioned during my talk today what dire straits condition the spotted owl population is in Washington. Hardly any spotted owls left. Nonetheless, this is an area where the Bart Owl removal experiment was very successful. But it's at the point now, whereas if you started going up into parts of Washington into the historical spotted owl habitat and removing barred owls, there won't be any spotted owls left there to recolonize. And so there's been discussion about translocations or captive breeding to supplement populations or augment them in those type of situations, which would likely be required for those situations because there's simply not enough spotted owls left to recolonize those areas once barred owls are removed. It's a different situation in parts of Oregon and certainly in California, where there's still, some spotted owls left in these landscapes that are reproducing that would be available to recolonize those areas. But you can see it's a very different situation depending on where you are within the spotted owl's range. Up north, it's become a very dire situation. It's starting to head that way in the southern part of the range. And that's why a lot of people are saying right now, we really need to be doing removal. Otherwise, we're just going to see the whole range turn to what we're seeing in the north.
Since you highlight the barred owl as the #1 reason for the demise of the spotted owl, how do we get federal agencies to not use barred owls as the scapegoats to continue to log in spotted owl habitat? There's a lot of push to log into the Sierras.
Yeah, that's a great point. And I certainly didn't want to give the impression that habitat is not an important part of this equation or this story. Clearly having suitable habitat, older forest conditions is a requisite for barred owl removal to succeed. You can't do barred owl removal without the habitat. Those two things go hand in hand for spotted owls. The way I look at it is that the habitat is the underlying resource that the two species are competing over. And so that is the critical piece that needs to be protected and retained. And then Bart Owl removal, which has become an immediate, more impactful and higher magnitude impact. That's a shorter term impact on spotted owls, needs to be dealt with. And so what we've found in this experiment and some of the work that we've done actually is that in areas where the habitat is in good condition and being protected, that you can do Bart Owl removal in those areas, and that you may be able to have self-sustaining populations over the long term, and may be able to reduce or even end Bart Owl removals given the habitat conditions in those areas. And so, and I'll also mention that the management agencies, particularly the Fish and Wildlife Service, view habitat loss as just as large of a threat as the Bart owls. It's just the Bart owl's threat is more immediate, and it's had a much stronger, more immediate impact. Also, by managing Bart owls, we see that impact reverse much faster. The impact of habitat loss or increases is a much more slower, gradual response in the population of spotted owls to those type of changes than what we see in response to Bart owls.
This one is from Sophie Heinmarch, who was our speaker last week, and relevant because she's working with barn owls in BC. And she said, yeah, so she said, I'm curious as to why you refer to it as an invasive, as it got here on its own accord. Barn owls had a similar expansion, but are not referred to as invasive.
Yeah, there's some debate about whether to call Bart owls an invasive species when I started this work, and for the reasons that you talk about. But basically, everybody talks about Bart owls as being an invasive species now, and that's because they're defining an invasive species as a non-native species that's entered the system and is having a negative impact on the native species. And so even though the Bart owl is not invasive in a more traditional sense that you think of an invasive species of being spread by humans, for example, you know, like zebra mussels or something like this, it's a similar impact in type of situation where this non-native species is having a negative impact on the native species. And so the Bart owls have also been, for this reason, they've been referred to as a native invader. So an invader that's became, or a species that's become invasive within its own native range.
And along with that, a couple of people would like to know what main factors contributed to the expansion of the Bart owl range. Like you said, you did mention planting a lot of trees, but was there other stuff that could have affected that?
Yeah, there's actually a really important, really interesting paper written about this by Kent Livesey that you can find in the Journal of Raptor Research on the Bart owl range expansion. He wrote a couple papers about it. But in one of those papers, he makes a pretty compelling arguments about European settlement and the effects that that had on Bart owls at the time. One of the more interesting effects that we see is before European settlement, the Native Americans were using prescribed fire regularly within the Great Plains region for their hunting tactics, so that they were doing prescribed burns in those trees to keep them down so that they could facilitate their hunting. As European settlers moved through there, that fire regime was changed pretty dramatically, and so those trees were allowed to grow up. That is one of the factors. Another factor that we think could have contributed to is beaver. And so with European settlement, there was a lot of beaver trapping that started to occur. And beavers are ecosystem engineers along these riparian corridors that we know Bart owls use for their movements also. And so by doing a lot of beaver trapping, there's also evidence of this in the ecological literature that that changed some of the forest structure in these riparian areas. And so that's another thing that could have allowed the barred owl to have these stepping stones of forests through the Great Plains region. And then there's the planting of the tree shelter beds and things around the settlements that we also see that may have also served as stepping stones for barred owls. And so we do see some evidence for some of what I'm talking about, and because the barred owl range expansion is actually pretty well documented through the museum record and through collections of the birds over this time, through different areas, through these riparian corridors of the Great Plain regions. And so there is some evidence that supports some of what I'm talking about here.
Okay, could you address spotted owls in California and like the Mexican spotted owl? I mean, is it likely that the barred owl is going to get there and have impacts on both of those subspecies? I mean, it sounds like they're already hitting the California ones now, but what about like the Mexican?
Yeah, it's really interesting because when I first started working on barred owls, they weren't too worried about them. The California spotted owl folks weren't really talking about barred owls, you know. Now it's all they talk about, that and fire anyway. And so, you know, I don't know what to expect for the Mexican spotted owl and if barred owls will make it all the way down there. But I will tell you this, some of the information that we've been looking at from eBird on barred owls is very interesting. You see that there are detections starting to appear in places of New Mexico. And so some birds beginning to move along that southern portion of their range in the southern United States potentially. And if they are able to get footholds up into that area, that may give them access into areas occupied by Mexican spotted owls. At this point, it's really speculation to say what's going to happen. But I do know that the original work that was done, that some of the predictive work about the barred owl range expansion and how far it would go has been kind of blown out of the water by what's happened. You know, barred owls are very adaptable. They're incredible species. And so they're starting to appear in places where, you know, people don't really expect them to be. And places like Southern California, for example, they're starting to appear very sporadically in places like that. You know, there's records of them being observed in like Palm Springs in California, places like desert areas. And so it's a very prolific adaptive species. And so I'm not going to be one to say, no, they'll never start impacting Mexican spotted owls. But right now it's looking unlikely. And it'd be really amazing if they were able to do that. I mean, but it's a pretty amazing species, and they've already shown us that they have quite an amazing capability to expand. So.
Do the spotted owls avoid the presence of barred owls, or are they actively chased away?
I think it's a bit of both. And so in the studies that we did with telemetry, we actually recorded both those things happening. We recorded, you know, we had one case, it was really telling of the situation because we had gone in and found a pair of spotted owls that had been known to occupy this particular area it had been monitored there. They were marked, and the same pair had been there for over 15 years. And so it was an older pair, and we marked the pair, and then the second year of monitoring, a pair of barred owls moved into their territory. And we were able to quickly capture that pair of barred owls, mark them, and then begin to monitor how all these two pairs were, you know, interacting with each other. And basically what we saw is the barred owls actively chasing the spotted owls out of their nesting core area. And then the spotted owls being excluded from that area. And so eventually the barred owls completely took over that nesting area. The spotted owls were eventually relegated to some small patch of forest that was pretty far from their original home range where they attempted to nest but were unsuccessful. And so, you know, that situation kind of showed how not only the barred owls are impacting spotted owls by physically chasing them and this physical aggression, but there's also the competition for prey and the forest resources themselves and those nesting areas. So the nesting areas are also a real point of competition between the two species, because those really provide ideal conditions for their nesting sites that both those species really key in on. You know, the large trees with canopy or cavities and things like that they can nest in.
Okay, so Sophie says thanks. And she's also noticing that barred owls are having a negative impact on western screech owls in BC also. And somebody else asked, is non-lead shot used for the lethal removal?
Oh, yes, yes. And interesting part of the project, we, the specific shotgun and type and everything we used, including the shot, was specifically designed for the project and as a tool to do barred owl removal. So we had these shotguns that were called quiet shotguns because they had a 6-foot extension at the end of the barrel that would suppress that loud crack of a shotgun. Also, we used non-lead shot. We actually, because we're using that quiet gun, we had to load our own shot, subsonic shot needed to be used. And because that couldn't be purchased readily in pre-made shots, we had to load our own shot and create our own for the project, so that we can use the specialized shotguns. And so that was all non-toxic, yes.
Have you seen effects of barred owls on other large owl populations like great grays or snowy, since they seem to overlap in some places?
No, we have not. And, you know, that's something that as part of my research and my research program that we're very focused on right now is learning more about impacts of barred owls on some of these other species, particularly the other owl species, the other native owl species. And so we are starting to learn that barred owls are impacting some of these other species. I think some of the other larger owl species that you mentioned, great horned owls and snowy owls, are interesting because I think the relationship between great horned owls and barred owls is very interesting. We just don't really know a lot. We do know that great horned owls are capable of predating barred owls, and one of really the only predator out there that barred owls have to worry about, I think, besides maybe some of the hawks. And so it's really interesting to think about the relationship, particularly with great horned owls. But if you think about it, great horned owls tend to be a species that occupies more fragmented landscapes. And they aren't found so much in these more contiguous patches of old growth where we find the barred owls and spotted owls. One interesting aspect of the dynamics that we've been talking about here is that as barred owls move into these contiguous patches where spotted owls are, they kick the spotted owls out. Now the spotted owls are kind of relegated to these more fragmented areas where there's more great horned owls. And then we're seeing increases in great horned owl predation rates on spotted owls. And so this is kind of this indirect effect of the barred owls now putting spotted owls and great horned owls more in contact with like one another potentially. And so I think that great horned owls are part of the story between these species as this other big owl and predator that's also pretty abundant in some of these landscapes. Snowy owls, we just don't encounter too many of them, and so it's really hard to tell how they might be impacting snowy owls at this point.
This person said at one time they read that the anti-spotted owl people, I assume back in the 90s, were killing spotted owls. Has that continued and played a role in the decline of spotted owls?
I don't think so. I think that pretty, it's pretty difficult to find spotted owls now to begin with, unless you really know what you're doing and you're already working on them. And even then, it's become incredibly difficult. And so, no, I don't think that that is an issue in the population declines we're seeing. I did hear there was some of that happening, you know, back in the 90s and such. But I don't think that it was happening at the level that, you know, could be contributing to these population declines we're seeing. At least I would hope not. I mean, but we've certainly seen no evidence of that. Well, let me put it that way.
Even after the initiation of lethal removal of barred owls, the graph showed parallel decline of both groups. What caused those parallel declines? And they were wondering if you could show those figures again. We'll see if that's in the books, but.
Yeah, that's a great point. The reason that the lines are kind of going back and forth together, that's the great part about the experiment. That's all the other sources of variation in the environment that are playing on those control and treatment areas. And so we see this natural variation between years that might occur in survival that's driven by weather patterns, for example, that would affect both the control and treatment areas and result in similar patterns like that. And so really that's the main one, or other things can also contribute to that variation to see that pattern. But what was important is that once the removals started, we saw a separation between the lines of the control and treatment. So even though they're parallel moving together, they're separated from one another. And so we're just seeing them move together and same type of variation that's affecting all the populations, probably climate, things like that.
Two questions from this person. Are there still as many barred owls in Eastern North America? And can you tell the difference between a barred owl pellet and a spotted owl pellet?
Oh, wow. Well, the first question, I think that, you know, there are some studies of barred owls in the Eastern United States, but not a lot. For really widespread species, there's really not a lot known about barred owls, but there are some great studies that have been done. I think it's hard to say what their densities are like, because I have not seen any studies that really survey barred owls in detail like we do that could estimate their densities. However, I have seen reports, and we know that their populations are expanding in some of those areas in their native range in the eastern US. And we know that's the case because those populations eventually expanded west. But, you know, I hear things, particularly like in places like Florida, and I don't know if anybody is here, is down in Florida watching barred owls, but I've heard that barred owls have become super abundant down in those areas. They're being found in palm trees and things like that. Makes sense to me because barred owls are really a swampland bird, and so should be thriving in that type of landscape down there. But I just don't know. I just haven't seen any work that's been done on barred owls in some of these areas. So some other folks on this call may have a better idea of that than I do.
And then can you tell the difference between a spotted owl pellet and a barred owl pellet?
Oh yeah, that's a good one. No, I can't. And so the way that we did it is that, you know, we had barred owls and spotted owls radio marked. And so we could follow that radio marked individual to its roost site in the day and look for pellets right underneath the bird. And we can pretty safely assume that's its pellet, and we got the right species. And so we kind of base it on that assumption. But if you take a barred owl and a spotted owl pellet and you look at them side by side, I don't think you can say anything about species.
Can you address the reproductive rates of barred owls versus spotted owls?
Yes, that's something I didn't have time to talk about today, but in the owl interaction study that I talked about, we also monitored reproduction and compared reproduction between the two species. And there was a crazy difference between reproductive rate of the two species. So the barred owls that we monitored, all the pairs that we monitored nested every year, and most of the pairs that we monitored were successful in producing 2 to 3 young. We had a couple broods that were 4 young of barred owls. In contrast, spotted owls are well known not to breed every year. Oftentimes they will breed every other year, and their success rate in actually producing young has been pretty low, especially recently, probably in another effect of barred owls. And so we saw a dramatic difference in reproductive output between the two species in that study, which partially explains what we're seeing with the population growth of barred owls, right? They were incredibly productive. It was amazing. The pairs nested every year, and many were successful in producing 2 to 3 young every year of the study. Not something that I've seen in the other raptor studies that I've done on other species. And so it's, barred owls are just very amazing species in that sense.
Do you have any idea on the timeline for creating the barred owl management plan?
Yes, it's on a 2-year timeline. And so they realize that the situation is very pressing. You know, the longer they wait on the decision, the harder it's going to get. And, you know, potentially the more barred owls would need to be removed, the longer they wait with that decision. And so there's a real push to get that plan completed and done within the next 1 to 2 years. And from my understanding, I've been loosely involved with the development of the plan, and I believe they're hoping to see some review drafts that would be available to the public, maybe even by the end of this year.
And in the meantime, there's no removal going on right now, is that correct?
That's correct for Oregon and Washington. In California, there is a lot of removal happening currently, and it's also increasing. So California has largely decided to take a proactive approach to barred owls. They see the destruction basically that barred owls have laid in the north to the spotted owl populations. And as they're monitoring barred owls moving down there, they want to take a proactive approach. So they've initiated removal programs in many different areas in Northern California. They also have interesting situations there because they have cases, particularly going into the Sierra Nevada that's occupied by the California spotted owl. They have, you know, kind of bottlenecks of forested habitat that could be going into those areas that could be quite defensible for barred owls. And so the initial work that's been done in California has been quite successful in basically arresting the spread of barred owls into some of those areas down there. And so they're taking a very proactive approach. It's very different than Oregon and Washington, where once our experiment ended, basically they're waiting now to see what happens with the management strategy, I think.
Long term, do you think fires and logging will remove enough habitat to inhibit all owl populations?
That's a good question. I think that, you know, I think somewhat of a balance has been struck with the timber harvest. And, you know, there may be some that disagree with me on that. But, you know, we have these large areas that are now protected. The habitat is protected for spotted owls. The issue is, and then, you know, we have these very intensive, the Forest Service has very intensive monitoring programs of just that habitat for spotted owls and what's been happening with that. And before the large mega fires that we saw in the Pacific Northwest in the last several years, they were actually measuring increases or recruitment of new spotted owl habitat into those protected areas. So these were areas that had been disturbed in the past that had now been allowed to grow back into the older structural conditions. And so they were actually seeing increases across the range in the amount of available spotted owl habitat until these large, massive fires hit that really took out large portions of the older forest types in Western Oregon and the large ones that have been in California the last several years. And so that really puts a bang in the amount of available habitat for spotted owls and has brought it back down. And so those gains that we saw previous to the fire have now been lost. And now we're seeing reductions. And so particularly, I mentioned the California spotted owl and how they're dealing with Bart owls, and they feel like, yeah, they might be able to get a good handle on what's happening in Bart owls. Fire is now the real issue down there and how they're going to deal with that, because it's starting to have major impacts on the owl populations down there, and it's become very widespread. So the new fire regimes that we're seeing because of climate change are certainly another big stressor to these populations.
Are there any other habitats that northern spotted owls will use other than old growth forest? And has that been changing in recent years?
Yeah, I think it's interesting. They have some variation across the range and the forest types they'll use. I think on average, as a whole, they tend to really focus on the older conditions. They really specialize on those conditions. But they also do fairly well in some areas, depending on the prey populations. So there's some areas in Northern California, for example, in the redwood regions, where spotted owls reach very high densities and do very well, even though the forests aren't as old or as structurally diverse as the older forests of like Oregon and Washington. Nonetheless, they find very high densities of spotted owls, historically anyway, down in those areas. And it's largely because of what's happening with their prey. Down in those areas, those woodlands are very productive for wood rats, which is spotted owls, one of their favorite prey species. And so if there's a lot of wood rats, I think, and they can find structural conditions that they need for their nesting, which is, cavities, large enough trees for cavities, that they can use younger forests like they are down there. But like I keep saying, that's really dependent on what's happening with their prey, I think.
And are they using different habitats in California and for the California spotted owl and the Mexican spotted owl, or are they both like old growth?
They're both specialized. They also specialize on the older forest conditions. Yeah, all three subspecies do. Yeah.
This person says, I suppose removal of Bart owl eggs from their nests to eliminate reproduction is not really practical.
Yeah, that's been proposed and thought about. There's been methods. Egg oiling is a method that's been used where you go into a nest and just oil the eggs and they don't hatch. And that's been proposed as a method here. The problem is that, wow, finding Bart owl nests is really hard. We did that for our telemetry study. And even when we had the adult female tagged and she's sitting on a nest somewhere, we would have trouble finding that nest. And so the amount of effort it took to identify nests, and even if a Bart owl is nesting or not, was very difficult, very time consuming, and very costly. So that kind of was a non-starter, unfortunately, because that would be one method that would avoid the lethal removal tactic. However, I will mention moving forward that there are new technologies that may become available that would allow disruption of reproductive potential of Bart owls, for example. And so, I think part of this management strategy that I've mentioned, a big part of it will be always keeping wide open for new methods, new strategies that could be implemented in this type of situation that's would not require lethal removal. And that's going to be a continuing pressing aspect of research moving forward as well.
Is there any thought to using or plan for creating like reservation areas for spotted owls of the old growth forest areas with exclusion zones surrounding those reserves where barred owls can be removed? So this would be similar to over in the UK, our gray squirrels are invasive to their red squirrels over there. So to protect the red squirrels, that was a strategy they used, to give them reservation areas with an exclusion zone around it. Is that a potential thing for spotted owls?
Yeah, exactly. I think that's exactly the type of strategy that they're looking at right now, is establishing basically a reserve design system for spotted owls. And within those reserves, there would be intensive barred owl management. And so really what a lot of the work that's being done right now is determine, how do we determine where to put these reserves? And there's so many factors that are going to affect where you place a reserve. And then once you decide where to place a reserve, you could potentially be tied to managing within that reserve indefinitely. And so you really wanted to pick well and carefully where these things go. And there's all kinds of details that need to be worked out, how close these reserves need to be to one another, how many there should be. Lots of complicating factors beyond just where they should go. And so I think that's exactly the strategy that they're talking about for spotted owls and barred owls.
Okay, another one that I have, and I know we've been asked this several times at the Owl Center because obviously this is a big issue and it doesn't have nice, easy answers. Would the extinction of spotted owls at the hand of barred owls be considered a normal process of evolution?
Yeah, it's kind of similar to the question that I often get asked. Are we disrupting natural selection process here between these two species? And so I think it's a tough one, but the way I look at it is that I think humans are a big part of the picture of what's happening with these two species. We've obviously determined with our management actions in the forest the trajectories that these species are taking. And so in that sense, I think that kind of ties us to, at some level ethically to the situation. Also, we are not just separate from the situation. As I keep alluding to, humans are part of it. We're also competing for those old growth conditions along with these other two species. Those are highly valuable forests, not only economically, but ecologically. And so these are just some of the things that that I grapple with. I'm not sure if that addresses the question or not.
Yeah, it doesn't have an easy answer. So
No.
yeah, I appreciate you
It's a
sharing.
really good question. But the way I look at it is that, I think humans have largely had a major influence on the trajectories that these two species are taking already. And so that in of itself is worth taking into consideration.
I'll grab this one that just came in. Won't barred owl killing management have to be done in perpetuity to save based on the reproduction rate and dominant behaviors of the barred owl? And what's the cost to manage them?
Yeah, those are some of the questions that I think they grapple with as they're putting together this management strategy. Because the removal experiment happened between 4 and 6 years, which is pretty long for a big field experiment like that. But then when you're starting about a management interaction that would be years and years of doing removals, and would that have to be indefinite and every year? I don't know if we know the answer to that. There's been some work looking at the interaction between Bart Owl removal, northern spotted owl persistence, and the habitat conditions that show that once you get to a certain point with removals and the spotted owl populations begin to really take hold, that you can at least lay off on Bart Owl removals and maybe not have to do it every year. And it would be more of an intermittent process, maybe once every 2 or 5 years, something like that, rather than every year. We just haven't done removals long enough yet to know if that's possible. Based on what we've learned from the experiment and the numbers that we've crunched, we show that it is, but it's just, we don't know, we haven't got to that spot. We don't know what that dynamic is once you do removals for longer than that. But I do believe that that is what they should expect in the management plan. That's once it's implemented, it would need to be done in, you know, not forever, but for a long time, perhaps. They would have to be very tied to it. Also, because if they started it and then decided it was too costly or something and stopped it, then that, you know, I would question the ethics of doing that, you know, going in and killing a lot of Bart Owls and then just giving up anyway. And so it's really a tricky situation, you know, once they make that decision, I think they really would need to stick to it.
And the other part of that was the cost. Can you speak at all?
The cost is something that we've begun to work out, because in a management program, you know, you're not trying to do everything so super controlled like you are in the field experiment that we ran, where, you know, we did very intensive population monitoring and things like this. And so it would be much cheaper than what it costs for our experiment. And there's some evidence that it would be pretty cost efficient if it were done in combination with some of the monitoring that's happening with spotted owls already. And so as they're going out and monitoring spotted owls and then maybe doing removals in these areas. I think the cost of whatever plan they put together will be a part of that plan eventually. And I think until they come up with what the size or the magnitude or scope of that plan is, it's pretty hard to tell what the cost is. But my sense is that it can be done pretty cost effectively because the Bart Owls are so aggressive, and people are pretty effective at removing Bart Owls.
And this person asks, why would you want to tag Bart Owls or spotted owls? I'm not sure entirely what they're getting at, but it's been asked a couple times.
Why would we want to tag them? Well, the reason we tag them is to be able to follow individuals, to be able to understand more about their survival and reproduction, or in the case where we tag them with small radio transmitters, those allowed us to, you know, follow the birds, determine what habitat types they're focusing in on, what they're eating, how they're interacting with other species, and so on. The large demographic studies that just use a leg band tag, those are very useful for just, you know, once they put a leg band on that bird, they don't have to go back and catch it every year. They can just see, oh, it has that leg band, and they can see the code that's written on there or the color combination of that leg band. And so by tagging the birds, it allows them to track individuals over years, and that's the information that produces the demographic information that we use to estimate population trends. You know, we're basically tracking survival of individual from one year into the next, as well as their reproduction.
And I'd just like to wrap up with one question that I have. Could you comment on the status of the different subspecies? Like the northern spotted owl is listed as threatened. Is the Mexican subspecies also threatened? And I understand California, they're relisting that one, giving federal status to it.
Yeah, well, the northern spot owl is currently listed as a threatened subspecies. It was actually uplisted to endangered status. And they found that was warranted, but precluded based on the current status of the Fish and Wildlife Service. So even though they had a determination that the spot owl should be uplisted to endangered status from threatened where it is now, the service decided that they basically didn't have the resources available to do that at this time. And so, yeah, it's been a complicated political thing, but basically the species, they found that it was warranted to be uplisted to endangered status, but that uplisting was precluded by other priorities that the service is dealing with right now, other species. In terms of the California spotted owl, it's been petitioned several times to be listed, but it's not a listed species at this time. But it's constantly being petitioned, and so that's kind of where that's at. And the Mexican spotted owl, I believe, is a similar situation as the California spotted owl.
Okay, thanks for addressing that, because when I was in college, I thought it was all about biology and what are the facts, and well, that's not how real life works. There's politics, and I can't even wrap my head around all the politics and the ethics and the stuff that you have to deal with working with spotted owls.
Yeah, I'm pretty sheltered from it, actually, compared to some of the other folks that work in the agencies and deal directly with the politics behind this stuff, which can get very intense, as you can imagine.
Yeah, I believe Rocky Gutierrez told me he felt he was fairly balanced in his handling of it because he got equal numbers of death threats, serious death threats, from the logging industry and from environmentalists. So he figured he must be middle of the road. But
yeah, he must be doing all right then.
Yeah, but I mean, literally death threats, and he's studying owls.
Yeah.
So I appreciate you taking the time to discuss this, because it's a delicate issue with, like, what are the right answers? There's just a whole lot of discussion around it and reasons for and against, and, and not making a decision is making a decision. And so these are things that at the International Owl Center, we have to educate people about, and to know the topic more in depth is extremely helpful for us. So I'm hoping I know there are some other educators watching too. Because I know some of us in the Eastern US that aren't directly dealing with it are not as aware of what's going on and the severity of the situation out there. So thank you very much for taking the time to share this with us. Thanks to everybody that joined to learn, and I hope a whole bunch more people watch this later on. I feel like this should be required watching for anybody who has anything to do with nature and wildlife, just on so many levels. And thanks to everybody that has donated to support this series so that we can keep it free so that everybody can learn wherever they are, regardless of income. If they want to learn, they can learn. And thanks, David, for allowing us to save this too, so people can watch it later if they weren't able to catch it live. Our next program next week is our last program of the series this winter. Oh, and I believe Joe posted in chat your webpage that has a link to your research, David, and hopefully that has been posted over in YouTube also, so people can find your research and your contact info there if they would like to. Next week is our last program, and that is European Owls Made to Hunt: Anatomy Shaping the Variation in Hunting Behaviors and Food Processing Among Owls, with Dr. Arnold Vandenberg and Cas Koenraads from the Netherlands. And like, this should also be required watching for anybody who does owl education, or anybody with any serious interest in owls, because I've seen Arnold do a presentation before and my head was about ready to explode with all this new information, because a lot of this is not in books, and a lot of it challenges what you see in all the owl books that are supposed to be the accepted facts. So it's based on direct dissections of a whole lot of species. And they're eventually going to be coming to the US when we do the World Owl Conference and leading dissections and learning more about American species. So this is a way deep dive into the anatomy and physiology and why things run the way they do and how owls are different. So highly encourage everybody to check that one out next week. So thanks very much, David, and everybody that joined us, and hopefully we'll see you next week.
Thanks so much for having me again. It was a lot of fun.
I'm glad you consider this fun. It's a difficult topic.
Yeah.
Thanks.
Take care.